You should all have access to Interactive Animation 202. It's a very exciting course for me, a very exciting module. I really think that the essence of storytelling lies in sort of creating this element of life. And well, essentially, that's what animation means, is to give life to something. And with character animation and interactive input, we're not only giving something life, we're also essentially giving another person control over this life form or this entity, and it's just really something profound about that. So if we go to the home page, it'll probably look something like this. So I'm going to run through these things as quick as I can. Course content is on the home page. A lot of this is in the brief as well. We're going to be doing the animation workflow and overview, which has a lot to do with like sort of motion capture data, animation files and clips, and then I think you guys mentioned rigging in Monday's major class, so we'll look at rigging just briefly. Some pointers, because there's also a 3D animation term that deals with rigging for animation and rigging for games. There's just a few things that you need to keep in mind. A lot of this course content is very technical, okay? And the reason for that is, there's this little expression that I like to use. There's a million ways to skin a cat, right? And there's literally so many different ways to approach this, but we're dealing with the most optimal way of working with animation files, working with rigs, working with the software that we prefer, so Blender and Unity, and then putting it all together in a way that would be, I would say, somewhat future-proof, because we're dealing with certain principles as well. We're not just tackling the step-by-step guide, but we're actually looking at how and why we do those things. So then after we look at the animation workflow, which is what we're doing today, we're looking at input system, so how Unity's input system works and how do we translate, let's say, actually how Unity translates sort of keyboard input to touch input to controller input. And what's nice about that is if you are making a game for some other device or other platform, those things are already in place, and we can go ahead and not worry too much about exactly which button does what. I mean, those things are simple to configure. And I think on this point as well, I would like to point out that I'm not inherently a programmer. I can read code and I can look at code and edit it until it does what I need it to do, but this is not my point of departure. I don't start with a blank canvas and then to start programming. I use, I'm predominantly an artist and a designer, and I like designing systems and I like game logic, and I'll put things together like that. When I work in a professional production, I would probably serve best as a technical artist, so I would work with or as an intermediate between like an art director and a lead developer, and that's normally where I fit in. But for this course specifically, I would say this is one of my areas of expertise in sort of rigging characters, animation, and sort of the crossover into the interactive realm. Most of the stuff that I'm going to be showing you is going to be visual code. So I use Bolt extensively. I used to use other things before that, but even when I used to create visual effects systems in something like Softimage, I used to use Ice for that, and I use animation nodes when I work in Blender. And so I normally work with node-based stuff, but I have also dabbled a fair bit in HTML and Python and so on. And the C# obviously, but I'm very familiar with what Unity is capable of, and the Unity API, because I work with Bolt. A lot of the heavy lifting, though, that we're going to be doing is done by the animator. So the animator is essentially a state machine. It's also a node-based system, but we're setting up all those parameters, and all we're doing with code really is feeding the animator little bits of information so it knows how to process or respond to the information that we give it. Then after we've dealt with the input system, we're going to go over to camera and controls. For this, essentially we're using Cinemachine. Cinemachine is a robust camera system that works with a number of different parameters and types of cameras and camera inputs and potential camera models and parameters that make your camera so much better than just starting from scratch or parenting a camera to a character like we've all done before. So again, this is the way that we'll approach it. If at any point our approach becomes, let's say, insufficient at doing what we wanted to do, we can build on top of that system, or we can sort of re-look at it and try and enhance it. But for most parts, we're going to stick to what Unity gives us and the tools that we have available to us. We have sort of people on normally on both sides of the camp, where the one is, you know, all for new systems and would immediately jump onto the latest tools so that they get the benefit from the tools, and then we have sort of the other side of the camp, which is more traditionalists, and they would go like, no, you're not allowed to animate, or you're not allowed to use motion capture data because it's not animation, or you're not allowed to use Cinemachine because you don't program the camera from scratch, or so on and so forth, or you're not allowed to rig the character in Unity because your rig should already be, or you're not allowed to use Mixamo because that's not a real rig. Now there are certain things like that. I actually am one of those people saying that you shouldn't use Mixamo for rigging, but I'll explain to you why. As for the other things, for the most part, I'm pro technology and tools. I think that your peers and your competitors going into the market are going to use the latest and greatest tools, and unless you're really, really proficient at doing something on a sort of a traditional way, you really shouldn't do that. And again, don't get me wrong, I'm not saying that there isn't place for traditional methods or methodology. You know, I love stop motion animation, and I think it's probably the worst possible way to want to make films because it's just so tedious. But again, there's a place and there's a time for it. For now, we're looking at the most proficient and the most or the easiest way to get to from point A to point B. And again, like I said, if we find at any point in time that doesn't work for us, we'll move back and go and change that and build on it. Okay, so then some things that you don't really have to be too concerned about now yet, but or you might not know what they are yet, but we're going to be looking at animation events. So exactly when do we change the collider so that your character can ski or crouch or move underneath things? How do we blend animation so that your character can run, but then also later run by picking up a gun, or creating certain masks so that animation can vary from one character to another, even though they're using essentially the same animator. Then we do procedural animation, so we look at I think it's still in preview, the Unity rigging tools. So how do we define the rig that we've built outside of Unity so that Unity understands it? There's a lot of that happening throughout. But in this case, what we can do is we can start driving some of the movement with external forces and parameters that we find inside the world. So you could, for example, say this arm should function as an IK unit, and next time you open the door, don't just look like you're grabbing the handle somewhere or in the proximity of the handle, but you actually give it the coordinates for the handle so that the hand and the arm actually reaches for it and grabs it. Or when it's going upstairs, that it doesn't just sort of like slide up looking like it's climbing the stairs, but that his feet actually hit the stairs. Or another thing that you can do with procedural animation is sort of build in a more sort of responsive idle state, so that when characters pass closer to your character, that he sort of fixes his gaze on them, and as they pass he loses interest again. And you could do all sort of really cool behavioral stuff with procedural animation. Then we refine our character controller, so we're going to make sure that all animations blend in nicely together and they look natural. When I say natural, I mean that it needs to adhere to the rules of physics within your parameter, or the parameters of your game. It doesn't mean to say that everything needs to be completely physically accurate. It just needs to be believable for whatever is happening in that world that you've set up. So we are building this sort of white box environment, which means that we want to build our character controller in isolation and then eventually export it as a prefab so that you can use it in other projects and recycle some of the work that you've done here, because it is going to be it's sort of a large chunk of work, and it's also going to be work that you can reuse at a later stage. So that's also cool, to think of it that way, that whatever you build now, you'd be able to use again. Like if you build a really solid third-person controller now, or a parkour style character animator, you could potentially use it for projects going into the future, or you could sell it as an asset on the asset store, provided you have the rights to all the animations and whatnot. Okay, then after we've refined and really honed in on the quality of the character controller, we'll look at using those or that controller for enemy AI or enemy animator instances, and then eventually we'll build this entire world that we've set up with certain physical triggers and sort of challenges, like a little slalom or some sort of a test ground for your character controller, where it can run upstairs and jump off ledges and things like that, just so that we make sure that it actually functions. Okay, so that's the breakdown. Sorry for staring at that screen. It's going to feature elsewhere as well. The module overview and the brief is sort of very similar. So there's a breakdown of the weeks and when we do that. So that's similar to the little thumbnails that we just looked at. Then there's a breakdown of your marks. So by next week, the planning for your character controller already needs to be done, and that's 10% of your mark. And then in week 4, there's a controller prefab that is another 20% of your mark that counts towards the practical component. And then there's an animation or animator documentation, which is basically a vlog that you hand in. It's another 10% of your mark. And then eventually your demo build is 60% of your mark. So that happens towards the end. So everything up until week 7 only counts towards 40% of your mark. This doesn't mean that you can't, or you should just ignore that. 40% is a great deal. And unless you're getting 90% for your demo build, you're not going to pass if you don't work consistently. So it's better to just keep up with the assignments, and don't miss them or don't skip them thinking that they're not important. This is probably the place where you lose your marks the most. Even if you hand in something that's incomplete, still hand it in. It's still worth something. Okay, we won't give you 0 if you've handed in something. Right, so the brief looks like this is not the brief. Excuse me. I don't know why I had that one open, but we can just try this again. I think you should be seeing a video of Gang Beasts here in the background, and the only reason why it's not showing for me is because I somewhere along the line messed up my cache of this brief, and I haven't had the time to go and reset it. But there you go, the deliverables again is in week 2 for the animation selection. we'll get to that soon. And then the controller prefab is in week 4. The controller prefab, what that basically is it's making a prefab in Unity is super simple. This is just, sorry, I was just checking bones and things on this broken rig, or showing people what it looks like when a regular rig is brought into Unity. But a prefab is essentially taking things that are in your scene or even in your project, and then if you drag them in, well, that's already a prefab. Okay, so let's say that's a prefab, then you'll just export that package. Okay, you can I think prefabs maybe using the wrong term here, because it's basically a Unity package, because you can include multiple prefabs in it and just export it, and it will basically zip it. It's all it is. It's sort of a proprietary Unity zip file, and then that's what you submit. So you just make sure that whatever your character controller is dependent on, that's included in the Unity package, and you hand that in, and that's in week 4. Then your animator documentation is basically going to be a vlog of you explaining how your input system works and what your character can do, and what you need to press to get that character to do what it needs to. So that's fairly simple, and your demo build, like I said, is just a sort of a white box world. Our focus areas is seamless animation, so everything needs to blend properly. Physical simulation, meaning that your character needs to behave like it needs to. That's physically accurate. So, bones pointing in the right direction, feet pointing forward, arms don't bend the wrong way if he runs, and things like that. Feet are on the ground and they don't slide. Those are just sort of a couple of examples of things that aren't physically accurate. And then it needs to have an intuitive control system. So we need to adhere to certain sort of expectations for input controllers. Like, if you use a controller that your joysticks are actually moving your character, and that's, I don't know, A is jump and B is crouch or shoot or whatever. Those sort of or spacebar is jump at least. And if you don't follow the sort of norm or the expected button configuration, that there's a reason in your thinking, like perhaps you're building this character for some sort of a dual keyboard input system, you just need to explain it. So that's sort of part of what that animator documentation is all about. It gives you a chance to explain why you've made the design decisions that you have. But then they still need to be intuitive, and they still need to be easy to access. So, if you want something that your character or that your player needs to do on a regular basis, like let's say shooting, for example, is something that it needs to do almost all the time because it's a shooter. Then make sure that you use a button that's easily accessible. Right. So yeah, Dr. Seuss said that you can control, or only you can control the future. Now that's a little bit left field. Dr. Seuss and games aren't exactly, on the same playing field. But what I thought, or what I find inspirational about this, is that you are absolutely in control of what your character does and when it does it. You are the puppet master of this character that you're setting up. So you need to make it work. Okay. That's the same breakdown of the marks that we saw in Canvas, and the applied theory means that the animator that you build is structurally sound, and that the animation that you've selected is appealing. We'll go through that once we've looked at all the animations that you've selected, and then functionality, everything needs to work, and also user experience goes in line with the intuitiveness of the controls. And then once again, there's the breakdown for the input system and animation transitions that we're looking at. Animation selection is what you hand in, so everything that's in bold is what you hand in. I think that's sort of a convention that you're used to by now. And then camera control schemes, rigid bodies and constraints, also what we're looking at. Animation events, procedural animation, refined character controller, which speaks to the aesthetics of the character controller. And then enemy animator instances and ragdolls. So actually the example here, Gang Beasts, uses a sort of a physical skeleton to drive the animations alongside the input system, which is also just a sort of a technique that you can apply using ragdolls. And it's fun, but we still build the animator first and then do the ragdoll system or the physical based skeleton later on. Some books that are available in the library if you choose to go and look for them. They all sort of deal with character controllers and characters and cameras to some extent. The Animator Survival Kit more so about the actual animation than the controller. So the first two references are game specific and the last one's more animation specific. Miro is useful for plotting out your character controller and planning what goes where and when it should happen. Bolt and Mixamo are just useful resources, but there are more, and they're also more linked to the class specific details on Canvas, which I'll go to now. Progress and planning. Yeah, I think it's very repetitive. Again, it just elaborates on what the animation selection actually entails. So in this case, we want you to sketch out and list the various animations and aspects of the character controller system you plan on implementing for your test build, including the various physical mechanics the character will require. So your planning documentation may be extrapolated from an existing GDD if you've already designed one or wrote one. Previously, our game design majors did a GDD in the first term, so I'm not sure if you guys did that or did something similar. But essentially what I'm saying is that if your character needs to jump, then you need to include it in your planning. You need to download the animation for the jump, and it needs to be part of what you submit. The same goes for shooting, crouching, crawling, wall running. Whatever your character needs to do, you need to have the animation sourced by next week. Okay, so I'm going to give you links to a bunch of libraries that you can grab animations from, and we can just, for now, you just need to document them, because getting them into Unity can be a little bit tricky. I'll show you how to get them into Unity, and but you might run into other issues along the way that we didn't foresee, and that I don't want that to completely stop your progress and not allow you to submit next week's submission. So what they've also done in the past is kind of just like screen grab or capture and then turn that animation into a GIF. Explain exactly what is happening in that GIF or what your source is, and then what you need it for. This is sort of a very rudimentary way of doing just that, and then submitting a document. Like I think I said slides on the brief, so you can just put it all in a slide. I don't expect you to submit anything other than the visual representation of it. So if you don't have it working in Unity yet, then don't use Unity, but I'm going to show you how to try and get it into Unity, string up your animations, and then you can just do one screen capture playing all your animations in sequence, and that could basically be your submission. Okay. Any questions on that at this stage?
Quick question. For like GD200,
Yeah.
I'm doing a 2D game, and I plan on doing kind of pixel art animation using a sprite. Does this term's hand-in have to be in Unity 3D using 3D animations, or can I kind of
Okay,
do this?
yeah. So in the past, what we've done is we've dealt with it as sort of a parallel workflow and say, you know, the this is true for 3D only, and then this is true for 2D. But um, there are just too many steps that you're going to miss out on by doing a 2D character, that I would rather do separate sort of little tutorials or something to show you what you can do for your major, but then treat this as an exercise rather than an actual project based application. And I think even like down the line you might start seeing, oh, you know what, I can save a ton of time by, you know, maybe taking a 3D character and then pixelating that, or pre-rendering it, or and then bringing it in, or this is what I can do with the rig, and this is how animation clips and things work together. Um, so we're approaching it from a 3D character's perspective, but like I said, I'll do like sort of like segments where I'll say, okay, well, let's quickly look at how this works in 2D. Or if you have any questions related to your project specifically, you can always book a contact session with me, and we can go through the translation of the information.
Okay.
Cool.
So for this, and then I'll need to work in 3D and make a 3D character controller with all the animation.
Yeah. Now, having said that,
Cool.
there's no reason for you to have a background in 3D per se, because all of the models and things and rigs we could source online. And the little bit of 3D that we do, they're also they make use of sort of plugins and existing processes that are fairly simple to keep up with. So if you're not very comfortable in 3D, it would still be possible for you to keep up.
Cool. Thank you.
Cool. So as you can see, there are characters with way different proportions to what this character looks like, and I would say like getting a standard source. It's all about the animation source. So if your animation source is a Mickey Mouse looking character with a really big bobble head, then you're going to end up with animations that suit that character and that behave in that way. And now if you apply that animations to something that doesn't resemble those proportions, it might act weird, and we don't want things acting weird. So try and match your proportions of your character, and that's why I would play it safe and start with the X bot or the Y bot, depending on whether it's a male or female character. And the only reason why I would distinguish between a male and female character is because men and women move differently, essentially. You can use, obviously, you can use male animations on a female character. She's just going to come across as a really butch, and you can use female animations on a male character, and he's just going to come across as really effeminate and sort of. So if that's what you want, just be aware that there's a clear distinction between the way that men and women move. It's got to do with their physical proportions. So women have wider hips and smaller feet, and that's why they move differently. And men have bigger shoulders and normally more upper body weight. Or rather, whatever. I'm going to just leave it there. Watch people move. It's important. Okay. So if we've now selected a sort of a base character for our animations, we can go ahead and source animations from here. Now, this is just where I quickly want to deviate, because in our previous session, we mainly focused on Mixamo and sourced all the animations from here. But Mixamo is not necessarily the only source of animations. You can go to the Unity Asset Store, and there's a ton of animations that you can source from there. So I don't think I actually linked it here, but there was also some time ago the Carnegie Mellon University did they had a motion capture suite and a motion capture suite, basically. So they'd set up cameras, and they had a space where they had people perform all sorts of arbitrary sort of human actions, and then they created this library of motion capture data that they then released. Now the motion capture data isn't particularly clean, and there are ways of cleaning it, and it's not always the funnest thing to do, to clean motion capture data, but nevertheless there are specific animations that you might need that Mixamo doesn't have, that you could go and source from there or from the Unity Asset Store. So the motion capture database looks quite crude. It looks like a website from like 90s, and I think the reason for it was probably because it is a website from the 90s. But if you look at the human interaction, interaction with environment, locomotion, running, walking, there's a list here, and they actually also tell you, if you just read, there's a more easy to use motion capture formats that are in BVH format. Now this is actually the one that you want to use, and that's why I listed the mocap database optimized here right underneath the Carnegie Mellon original files. So that's the one where it's cleaned up, and these are the files that you can actually use, but I just wanted to include this so that you can sort of know where it's coming from. If you open this one, I think it's a Google site, and then over here there's a so this is where you can download them. Motion builder friendly. Okay, so I forgot which one of those is the actual one that you want. I think it's motion builder friendly because what you want is BVH files in the end of the day, because Blender natively supports BVH, and then you can import these and work with them separately if you need to. If you need to clean them up, then you can go file, import, and there you'll see there's motion capture files.bvh. Okay, so I don't, let me see if I do have one available. I didn't download one already, but maybe I've got one with some luck on my computer. I'm not going to spend too much time looking for one. Okay, there might be some here. Motion capture files, BVHs. Okay, so there's a golf swing, import BVH, and then that's basically what the motion capture file looks like. Okay. This can then be exported as an FBX. Unity used to support BVH formats, but it doesn't anymore. So you would need to export those as FBXs eventually. That's the only snag. But then there are very specific animations in this library. So I'm just trying to see. So those are the BVH libraries. There's the list of motion capture files for the specific libraries. So there's like playground, climbing, hanging, sitting, jumping, balancing, sword play. There's like dancing like a chicken. There's basketball. There's walking. There's soccer. So there's a ton of motion capture content. Now, it's not to say that you should only use motion capture files, but just to give you an idea, normally on any animation production, so whether it's a game or an animation, if you need to see it through its entire production process, about 2/3 of that is spent purely on animation. So that means just to complete this exercise, you would need to spend roughly 6 of the 8 weeks purely on making animations for your character, and we actually don't have time for that because we have too much technical information to cover in that time. So it would be better for you to use motion capture data whenever possible, and then only in the extreme scenarios where you really can't find something that your character needs to do, then go and animate that, and then we bring that in as additional animation. rather try and go and tweak the motion capture data so that it suits your needs. Like I said, there's a ton of these things around. I'm sure you get something that works for you. And it's not to say that it has to be exactly the same thing as what you want it to. I've used stabbing motions for punching, or I've used someone grabbing a like something off the wall as like a slap animation or whatever. There's things that you can tweak and you can sort of fake to, and especially if you can start combining that with more procedural inputs. There's definitely ways of getting around using the exact same animation as the one that you're looking for. So, and then on top of that, there's also a way where you can actually motion capture your own movements so that you still don't have to go and animate it. There's a service called Radical, and they allow you to use your mobile phone to record and upload movement, and then it says it uses an AI engine to then translate that into motion capture files. And I guess it does, but sometimes I swear there's just another like factory full of people somewhere in Asia converting your files for you. But yeah, no, I can't say for sure. It doesn't always turn out great, and there's certain things that you shouldn't do. Like if you turn your character around, then all your bones tend to like intersect, and it doesn't work with everything. But it works in some cases, so it might be worthwhile doing one or two animations like that. Technology is becoming more and more advanced, and these things are going to get easier for us to do. I think with some of the more recent, like iPhone ranges, they have LiDARs already, and that sees true 3D. So motion capture is just going to become easier and more accessible with time. Okay, so yeah, that's another tool. And then to review all of these things, because as you could see, like importing BVHs and importing FBXs, like an FBX becomes even more like trickier. Like if I just grab an FBX from one that I downloaded from Mixamo last time, even that has like a ton of parameters that needs to be set, and then only once you've imported it, you can already see that there's a massive difference in the scale. And now I've imported this FBX, and all the bones are sort of pointing in different directions. The movement is there, but it looks weird. Let me just try that again. So if I import an FBX, let's do the walking one rather, and this time around I'm just going to say automatically orientate the bones, and then import that. Now I have something that looks a little bit more like a skeleton other than that one. It's going to hide that, and you can see the walking animation. Okay, something that you might notice in a lot of this motion capture data though is that they don't always have feet animation, because a lot of them are, yeah, so their feet don't work properly. Now there's a way to work around that in well, especially if we use a procedural rig, then you can make sure that your feet stays to the ground, so the motion capture data would still be useful. But some of the Mixamo ones actually include eyes and jaws as well in some cases, whereas the BVH information really only does your neck and head movement, so it doesn't have like looking around animation. And again, something that we can fix. You know, all of the information that we can get from it is still useful. So yeah, like if you want to avoid having to import each and every single animation clip to check what it's like, because you know, with all the BVHs and you know, looking at a BVH library like this one for example, it can get quite cumbersome. So what you want to do is you want to get a program called FBX Review. FBX Review is proprietary software. Well, FBX in itself is actually proprietary format developed by Autodesk. And the only reason why Blender could eventually support FBX is because they reprogrammed the entire FBX format from scratch, because it's not open source. That's the problem with Blender, and it was a big sort of hurdle for them to overcome, is to look at all the proprietary things that they want to include in the software, but don't have the licenses for. They technically needed to rebuild it from scratch, because everything that is in Blender needs to stay and always will be open source. So that code that's technically proprietary was rewritten so that people can reuse it and use it however they please. So FBX Review is a free download, and it's just useful because it allows you to view all these files. So if I just open a FBX or a BVH file directly, I just double clicked on it in FBX Review, you can very quickly just play through this and you can see what that animation looks like. Okay. And remember, you can also chop your animations. You don't have to use, you can use portions of it. You can use either the upper body or the lower body of it. So we can sort of segment it as however we want to eventually. And documenting this process of gathering all the animations that you require for your specific character is what you need to hand in for next week's homework. Okay, that doesn't sound too complicated. So it means that if you go and source your animations from Mixamo, you download them and then you capture, or you can capture them straight into Mixamo, but I would prefer that you download them and have them ready, because the beginning of next week we're going to import all these animations into Unity, make sure that they're all useful and work, and we're going to string them up in the animator and start working with the input control system. Okay, does that make sense to everyone?
Quick question.
Mm-hmm.
Sorry. How complex does the character controller need to be? Kind of, is there certain actions that the character controller has to have, or is it kind of
okay?
What are the parameters for that?
Okay, so I would say that in most cases I prefer quality over quantity. So I would rather have you build a controller that is solid and doesn't have glitches and defects than building something that does absolutely everything. You can get really out of hand with building, like a combat system could be so robust that you have layers and layers and layers of actions and blend trees and things like that. So I would say your minimum requirements would be to build a locomotion controller, so something that responds to movement, and that should at least include one speciality. So it should be able to crouch, or it should be able to jump, or it should be able to do both, or whatever, but something other than just walking around the scene. That should be sufficient. You'll find that adding little things or adding one animation at a time doesn't really overcomplicate your character too much, and it's nice to spend time playing with the character. So what you want essentially is something that, once it's in the white box world, entertains the player for a period of time. So if it can only crouch, but you haven't really set up the world to facilitate that, then it's not going to be like very impressive. But then again, if your character only jumps, but it's like a really cool jump, or it's like really bouncy, and you set up your white box world to have a lot of platforms and moving things, and it's engaging, you could probably get away with building a controller that only jumps, and does that well, and that's it. Um, Although I would do, like, if you do a jump, then I would do a fall or something at least to sort of support that. Like if it jumps from too high, that it maybe it like splats flat on the ground and then has to get up. So there's a little bit of uh, a story within the controller itself, or a little bit of personality at least. Um, we normally,
Going
yeah,
to that, making it feel more realistic.
yeah,
Kind of, because if you can jump but not fall, then
yeah,
it doesn't make sense.
yeah,
Okay.
yeah. And you can also do, um, you can do a lot with a very basic controller, like something that just walks around, or walks really slowly. You could still give it a lot of personality by maybe adding something like a random idle cycle. So you have a few idle sequences where maybe it looks around, maybe it taps its foot, maybe it picks its nose or scratches his head, and it does that at random. Then you're going to start feeling, and you mix that with like procedural animation. You have other characters walking around doing exactly the same thing at random intervals, but they sort of glance at each other. You could get almost create a sense that there's uh, um, a life, like there's a society or something that of these creatures or characters in interacting with each other. So yeah, you can get quite far with doing something simple. Um, yeah, and you get a lot of different types of controllers as well. So I think this is where you need to figure out, like, do you want your character to run, um, like, okay, let's say for example you're doing a 2.5D character, then it's only basically going to run in one direction and have a turn animation, and then run in the other direction. Um, then you have a fairly simple controller, because then you don't have to download animations like strafing, or um, uh, maybe it only runs and it doesn't walk, so there's no transition necessary for from walking to running. And maybe it also, it's quite a snappy controller, so when you press forward, then it starts running quite quickly. Like maybe it's like a little, um, staunch little Mario type character, and it just sort of dashes immediately. Then you also don't need to worry too much about the transitions. But if you want something that's like ultra realistic, and you want it to, go from a stop position into a walking position, or walk cycle gradually, and also when it stops, it needs to sort of stop and give a sort of a little bit of a sidestep, then you need to be more attentive to the types of animation that you download, and you would probably go and source, like you can, if you go onto Miximo's website, there's a ton of things like, um, if I just say stop or start walking, there's run to stop, and those sort of things. If you want a controller that is really refined, those are the types of animations that you also need um, to source. Um, Now, when you're sourcing animations, there's a couple of things that you can change in Miximo, that's specific to Miximo. Um, like the BVH library that I showed you just now, though you can't really edit those. If I go and look at that BVH file, you'll see that, um, those keyframes are pretty much on top of each other, and every bone is keyframed um, for every single keyframe, and it's good for motion capture data, because it means that you don't have floating bones and things going, um, in weird directions. But if you think about it, every single bone here now has, geez, what are those parameters even? Well, essentially three parameters, right? So X, Y, Z rotation, and for every bone, in this case, there's, there's 19 bones. So that's 19 times XYZ for every single frame. So that's kind of where, um, like Unity can crunch a lot of this animation, but if you're now talking about layered animations, and you want Unity to perhaps look at the translation of some of the bones on top of that, the animation data, and also if you're talking about 1,000 frames, sometimes your animations are really long. That animation data can bog down your system and can make your game really slow. So you want to make sure that you use the optimum amount of animation, and you want to make sure that the animations that you bring in are also optimized. So there's a number of things that we can do to do that. When we build the rigs for our characters, for example, we tend to try and get rid of, like, 19 bones for a character is actually really really low, and the reason for that is, well, this guy doesn't have any fingers, he doesn't have any appendage, he doesn't have feet, and he doesn't have toes, and he doesn't have fingers. So that's basically where they scrapped all that. I think normally you would end up with something like 25 or something like that if you have mittens, meaning that you have sort of index fingers to control the hand, and thumb bones. So you basically have 6 bones for the entire set of fingers, and then obviously you get more complex from there, depending on what your character needs to do. And again, now you need to think of what type of game do you actually want to make. We're essentially building third-person controllers, right? But it doesn't mean that you have to lock the camera to a third-person view. You can put the camera right in front of the character, essentially making a first-person game. But then most of your animation clips that you're going to get need to focus on the positioning of the arms, and how they look from that perspective. You can also do a 2D game, meaning that you're just locking the camera to a side view or an isometric view. That's also fine. But then try and work with the parameters that you have at hand. If you're building a rig for your character, then don't include all the fingers and all the toes, because they're just not visible, and they're not necessary. Try and optimize and make it as light on your system, or the player's system rather, because some people, I think you're in a quite a fortunate demographic, taking for granted that you're studying at a private institution. You probably have a decent rig, and that's capable of running games and playing these things. But some people are going to want to try and play your game on a potato, and you need to accommodate for that as well. Right. So editing this becomes tricky. You can go and try and clean it up. So I think if you go to your graph editor and then you select all your frames and you go to keys and say clean keyframes, you'll see that it did somewhat of a reduction, but still there's quite a bit of cleaning to do, and it's possible, but it's painstaking. This you'll do like once you've almost finished your entire character controller, and you realize, oh, you know what, there's a little bit of a popping, or there's a little bit of this or that sneaking into my animator, and I don't want it there, and it's because of the source. Then you can go back to the source, you can clean up the animation, you can re-export it, and you can reapply it to your character controller without breaking anything. You're not going to lose any progress. I would do that at the very end. And again, same with custom animations. We do that at the very last moment when you realize that, okay, there's no other way to go about it now. I need him to do this one particular action that I just can't find anywhere, or it's just not working the way that I expected it to. Then you can go ahead and do that. Okay.